So, we're going to start by looking at section 3.3. I hope to almost finish this by the time we leave for lunch. And then after lunch, we'll look at 3.4 because the two really go together very well. They're the same sorts of ideas, just in two slightly different contexts. We need to talk about where functions are increasing and decreasing, and not absolute extrema anymore, but relative extrema. So to get us started, I would like to look at a graph like this. Is there a highest y value that I reach? No, how about a lowest y value that I reach? You have to actually reach them. Infinity is not a number. That doesn't count. This thing has no absolute extrema. It would if I was looking at it over a closed interval, but no, I'm looking at this over the entire real number line. However, this is something important. This is something important. I'm going to call this point over here my relative maximum. And I'm going to call this point my relative minimum. And all this means it is not the highest point on the graph, but it's the highest point for part of my graph. We can be more formal, but I think this is good enough for what we need. Relative minimum is not the lowest point on the graph, but it's the low point for part of my graph. There's some other features of this, though, that we have to talk about. I think until I get to my relative maximum, my graph is going up, and I'm going to call it increasing there. Yes?
Can any point be the relative maximum or relative minimum?
Yeah, that's why I didn't want to give like the actual formal definition. The formal definition says over some sort of open interval, the highest y value we reach on an open interval. Let's talk more later. That's more than I want to get into right now. Between the max and the min, we are decreasing. The graph is going down. And then at the end, I'm increasing again. Our goal for the first half of class is, if I give you a formula, can we figure out where we're increasing, where we're decreasing, where we have a relative max and where we have a relative min? And before we do any of this stuff, I need to give you a couple formal definitions that we're going to use to figure out our increasing and decreasing ideas. So we can see the graph and the definitions. Increasing and decreasing. F is increasing, where here's our definition. I'm increasing over here. What do you know about the derivative there? Positive. Positive slope means increasing. My definition of increasing is we're increasing where f prime is positive. I'm going up there. What's the definition of f decreasing? F prime is negative. F is decreasing where f prime is negative. Not going to bother with the other case. If f prime is 0, we're just not doing anything. We're just left. We don't have to talk about that. That's not a big deal. Let me give you the definition of a relative max and a relative min. The actual definition, not is the highest point for part of the graph, but the real definition and how we're going to find things. Relative extrema. And what I'm about to talk about is sometimes referred to as the first derivative test. Relative extrema, what we're going to talk about, is called the first derivative test. Before we start, these can only occur at critical values. We talked about finding those critical values last time where the derivative is 0 or undefined. So my first part of the definition of a relative anything is if x equals c is a critical value. We first need a critical value. Then f has a relative max at x equals c if here's my relative maximum. What is f prime before the relative max? Positive or negative? What is it afterwards? My definition is I'm going to have a relative max if f prime changes from positive to negative at that x value. F has a relative max if f prime changes from positive to negative there. Well, positive means I'm going up, negative means I'm going down. Sure, that means I'm going to have a maximum there. Similarly, I'm going to have a relative minimum somewhere at x equals c if f prime changes. Look at your graph and tell me how f prime's changing at the minimum. What? Eli? Negative to positive. And if I draw out a little negative slope and a little positive slope, I'm saying, yeah, there's a minimum there. These are the definitions we're going to need to work with for this section. Increasing, the derivative is positive. Decreasing, the derivative is negative. Relative max occurs where the derivative changes from positive to negative. Relative min if the derivative changes from negative to positive. And if I have a critical value and my derivative doesn't change sign, it's positive before and positive after, there's nothing special there. Oh. Hello? Hi. That's okay. Absolutely. Yep, bye. John, when we go for lunch, go see Mrs. Chase quickly. Alex. Danny, are you still writing?
Okay.
Is anyone still writing? Okay, let's see how to use this definition to actually do some problems. On the next, well, actually on my next page, we are going to find where f of x, is that on the screen? Sort of. Find where f of x, which equals x cubed minus 3 halves x squared, is increasing, and where it is decreasing. Also, determine the coordinates of relative extrema. And there's one other part I'm going to add in here that we'll talk about when we get to the end. We are going to say justify your answers. That's an AP thing. We're not going to bother with that until the end. Our goal is to find where this function is increasing and where is it decreasing. We'll also figure out coordinates of relative extrema, relative maxes and relative mins. And we're going to have to justify our answers by the time we're done using some rather specific language. I need my critical values. That's going to be step number 1. Find your critical values. I'm going to add a little bit more to that in a moment, but right now quickly find your derivative, set it equal to 0, and stop. Maybe leave like 2 lines after that. I really don't want to pull that up because then we won't be able to see the screen, so whatever. You're finding critical values, right?
Yep.
Hush. Oh, this should be kind of nice. X equals 0, x equals 1. Something now from the summer work is going to come back. I'm going to find the critical values, and I'm going to plot these on a number line, and I'm going to label that number line f prime. Find the critical values and plot these. Thank you, Paige, if you don't mind. Thank you. And plot these on a number line labeled. Okay, we'll take it. Can you stop by after school? Perfect. On a number line labeled f prime. So I'm going to make a number line. I'm going to label it f prime, and I'm going to say 0 and 1. Find the critical values. We did that. We plot them on a number line. I'm labeling it f prime. The point is, I want to figure out where f prime is positive, where is f prime negative, and it can only change signs at those critical values. So we're going to do what you guys were doing over the summer with the inequality stuff, where you made your number lines and you tested the regions to figure out, is this whole region positive, is this whole region negative? And that's how we're going to kind of figure out the increasing, decreasing stuff. Step number 2, we are going to test each region to determine the sign of f prime. And judging by what you guys have shown me on cumulative reviews with this stuff, you guys know how to do the inequality stuff. I do want to do the first one with you, but we were pretty good with this stuff. No, we were okay with this. Now, there are a couple places I could be plugging things in. Should I? So I've got my 3 regions, plug in something greater than 1, between 0 and 1, less than 0. Should I be plugging into f or to f prime? Why? Yeah, and I want to know, is f prime positive versus negative? So I'm plugging into f prime. It's going to be easiest if I plug into the factored version rather than the original version. Plug in something greater than 1. Fine. Positive? Positive. So I think your entire sign, because a positive times a positive is a positive, I'm going to label that region as positive.
Do we have to do that like 50 today?
That may help, but I don't actually have to see it. If you just go through the thinking for that, that's good enough for me. Plug in a half. That's a good value between 0 and 1.
Positive times negative.
Yeah, should be positive there, negative there. I don't care about specific numbers I'm going to get for answers, just that a positive times a negative is a negative. And what are you getting over here?
Positive.
Plug in -1, negative, negative, gives me a positive. It's important we label the number line f prime, because eventually we're going to have several number lines, f prime, f double prime, f, all sorts of things. I'm also going to put a couple symbols over here. I'm going to put a little symbol above that, an increasing symbol, a decreasing symbol, an increasing symbol. And I'm done with like the hard part. Now I just have to answer the question and justify using some proper language. Step number 3 is going to be analyze the number line and justify your answers. I'm increasing where f prime is positive. So I think I'm increasing here and I'm increasing here. I'm going to say that I'm increasing, again, hopefully remember this notation from that summer stuff, between -infinity and 0, as well as 1 and infinity, because I see the positive thing on my number line. Now, the issue is the College Board expects you to justify your answers in language. The number line is a perfect thing to be testing the regions, but we need to explain why we're increasing. The explanation goes back to our definition. What's the definition of f increasing?
Has a relative...
No. May?
Increase.
Where f prime is positive. I'm increasing there. Why? I'm increasing there because f prime is positive. That's what they need. And I'm going to be lazy and just do a plus with a circle around it. Good enough. But you got to explain it in words. It is important that you say because f prime is positive, not because it is positive, because I've got a couple functions. F prime, you've got to be very specific in your language. Go do the decreasing part right now. Tell me where we're decreasing and justify it, again, based on the definition. I'm saying between 0 and 1 because f prime is negative. A relative max occurs where we change from f prime changes from positive to negative. Do you see f prime changing from positive to negative on the graph? 0 or 1? 0. By the way, one of the reasons I'm putting those little symbols in there is, don't you kind of see like a maximum there as I'm going up to going down? That's going to be a maximum. There's a relative max at 0, comma. I need coordinates. Hold off on the second part. I'll do that in a moment. And I'm going to say because f prime changes, but we need to be more specific, from positive to negative. However, I want coordinates. I need to find the y-coordinates. How am I going to do that? Hands. How am I going to do that? Ryan? The original. The original always tells you y-coordinates. No matter what we're doing, we're going to get y's from the original. So 0, comma, well, whatever f of 0 is. F of x was x cubed minus 3 halves x squared. That is 0 minus 0. Relative max will be at 0, comma 0. Do you get what I've done there? Can you go deal with your relative minimum? Try it. I think you should be able to get the x coordinate easily. Find your y and justify things. Minimum at 1 comma something because f prime changes from negative to positive there. I think you should be doing the problem f of 1 to get your y value. So 1 minus 3 halves, negative a half. If I looked at the graph of this thing, there would be a maximum at 0, 0, a minimum at 1 comma negative a half, increasing at the start, then decreasing, then increasing. And we'll put all these ideas together in a couple days to actually sketch this thing. Not ready for that right now. We're just analyzing these. Anything on this process? I want to show you 2 more examples. Like I commented yesterday, I want to try to make sure I show you enough different types of functions for you to be able to work with so we can go through like the algebra and that stuff. So we'll at least start this second one before lunch. I want to go do the same analysis for the function f of x equals x squared minus 4 to the 2/3. I would like you to go find the derivative and see if you can also find your critical values. See what you can do with that. I hope you're not forgetting about chain rule. That's important. Maybe a little more than slightly. Guess I could factor. I might as well. And I'm getting that. And I guess after lunch we'll find our critical values and test the number lines and all that stuff.